Trig by hand. Are there any angles that I can stick into these trig functions and find the correct ratio by hand? And the answer is there's only 3 right now that I can work with: 30 degrees, 45 degrees, and 60 degrees. And that's because of those special triangles we've learned about. For example, this is a picture of a 45, 45, 90 right triangle. We have learned that the sides of such a triangle always come in the same pattern, namely x, x, and x root 2. Let's write down the simplest example of that pattern, which would be each leg measuring 1 and the hypotenuse measuring the square root of 2. This picture is so important. Definitely one that you want to have memorized. Well, with that picture, I can fill in any of the trig functions that I desire. Sine of 45 degrees. Let's see, I should pick one of the 45 degree angles to be the one I'm particularly focused on. Obviously, either one would be fine. That would make this the opposite side, this the adjacent side, and we already know the hypotenuse. Sine, the sine function, returns me the opposite side over the hypotenuse. Now, we always simplify our answers unless there's some reason not to. Here I need to rationalize the denominator to get a simplified answer. So multiply top and bottom by square root of 2, and I end up with a final answer, square root of 2 over, let's see, root 2 times root 2 would be root 4, which is 2. Sine 45 degrees, root 2 over 2. Cosine 45 degrees, that would be adjacent 1 over hypotenuse root 2. That's the same thing. So obviously when I rationalize the denominator, I will also end up with that same value, square root of 2 over 2. Tangent of 45 degrees, opposite over adjacent. That's 1 divided by 1, which is of course just 1. The other 3 can be formed quickly by simply reciprocating the first 3 values. When you have rationalized the denominator, like I had to do in this top example, it's generally easier to reciprocate the unrationalized version. Remember, I want my square root to end up on the top, so take the one where the square root is on the bottom, turn that upside down, and very quickly you'll get a nice answer for cosecant 45. If sine 45 is 1 over root 2, cosecant 45 degrees is root 2 over 1. We always simplify, and so this just simplifies to the square root of 2. I could have used this root 2 over 2 and flipped it upside down. Then I would have had to rationalize the denominator and reduce. It would have taken a lot more steps. So make your work as easy as you can. Obviously, since cosine 45 is also 1 over root 2, the answer will come out the same here, root 2 over 1 as the reciprocal, simplifying to square root of 2. Cotangent 45, well, the reciprocal of 1 is just 1 over 1, which is 1. So same value. These angles, 30, 45, and 60, because you can work with them by hand, they come up over and over and over as you're studying trig. In fact, I would suggest highly memorizing these values, at least for the big 3. Get some flashcards, put sine 45 degrees on one side and root 2 over 2 on the other. Do the same thing for the other of the big 3, cosine and tangent, and memorize those values. You will not regret it. The other 3, of course, you can always just get by taking reciprocals. Well, let's take a look at the other angles we can work with by hand. Again, why 30 and 60? Well, because we know something special about the 30, 60, 90 right triangle. We know that the sides come x for the shortest side, x root 3 for the medium side, 2x for the longest side. Simplest version would be 1 for the short side, square root of 3 for the medium, and 2 for the long. Very important picture. Once again, make sure you know this very well. Sine of 30 degrees. Let's see. Remember, if I'm focusing on 30 degrees, that would make this the opposite side, this the adjacent side, and this, of course, the hypotenuse. So sine 30 degrees, opposite over hypotenuse, comes out to be 1/2. Cosine 30 degrees, root 3 adjacent over hypotenuse 2, root 3 over 2. Tangent 30 degrees, opposite 1 over adjacent root 3. This one needs to be rationalized, and after I do that, I obtain a final answer of square root 3 over 3. The others are just reciprocated, so cosecant 30, 2 over 1, which simplifies to 2. Secant 30 would be 2 over root 3. That one needs to be rationalized. Final answer 2 root 3 over 3. And then cotangent 30, let's use the unrationalized version that we had before. When I flip that upside down, it's very easy. It's just root 3 over 1, which of course simplifies to square root of 3. So here are the 6 ratios that came out using 30 degrees and doing our work by hand. 60 degrees, we ought to be able to do those pretty quickly. Now keep in mind, when you switch to 60 degrees, now this is the opposite leg, and this is the adjacent leg. You got to be careful with that kind of stuff. So, sine of 60, I think you're going to see a lot of the same answers. It's the same triangle. Sine 60, opposite would be root 3, hypotenuse 2, so root 3 over 2. Cosine 60, adjacent over hypotenuse, 1/2. Tangent 60, opposite over adjacent, root 3 over 1, which simplifies to root 3. The other three are going to be the reciprocals. We've already done the reciprocal of root 3 over 2. That became 2 root 3 over 3. Secant 60, let's see, reciprocal of 1/2 would be 2 over 1, which is 2. And reciprocal of root 3 is 1 over root 3. We have simplified that as well. That became root 3 over 3. Once again, I would say memorize at least the big 3 functions for these 2 angles. So make flashcards with this information, sine 30 degrees on one side, the ratio on the other, etc., as well as for this information. These values will come up many, many times as we learn trig. So if I ask you to show work by hand, what am I looking for? Well, let's take a look. Let's say we wanted to find cosine of 45 degrees by hand. Well, the only way you can go by hand is to use one of our special triangles. So I would be looking for the 45, 45, 90 triangle. You're understanding that the sides, the simplest version of that triangle, come 1, 1 square root of 2. Cosine 45, of course, is the adjacent over the hypotenuse. So you would write that down, and then you can show me how you are rationalizing the denominator for a final answer of square root of 2 over 2. That's plenty of work by hand for that problem. Here's an interesting one. Find theta, find the angle in question if the tangent value, the tangent function for that angle, sends out a value of square root of 3. Well, how in the world would I do that? If I'm going to do it by hand, it must have something to do with one of my special triangles. It certainly isn't the 45, 45, 90 triangle. There's no square root of 3 in that. When I see square root of 3, I'm supposed to think, oh yeah, there's a square root of 3, isn't there, in the 30, 60, 90 triangle. So let me draw a 30, 60, 90 triangle. I'll label the sides. The one opposite the 30 is 1, opposite the 60, root 3, opposite the right angle is 2. That's the simplest version of that triangle. Now the other thing that I have to think about is, why am I looking here at something that's not in fraction form? Well, it must have simplified. In other words, it must have been square root of 3 over 1, which simplifies to square root of 3. Well, that helps me because I know that the tangent function sends me out the opposite side divided by the adjacent side. So I go to my picture and I'm looking which of these 2 angles here has an opposite side of root 3 and an adjacent side of 1, and of course it's the 60-degree angle. The opposite side is root 3, the adjacent side is 1, which means my angle, the angle I was looking for, must be 60 degrees. That's plenty of work to show by hand. Thanks for watching.